So we've got a question here: solve 35a plus 55b plus 121c equals 1. And a, b and c are to be integers. Obviously, if this was to be fractions, we could find some number to put in there for a, b and c quite easily. So now, what way we're going to use is Euclid's algorithm. So Euclid's algorithm. That's one way. There is another way, which will be on a link in the bottom for another video, which shows you a different way of solving a similar equation. Okay, so Euclid's algorithm, what we need to do first is find some common factors between all the three coefficients of a, b and c. So first of all, let's see what 35 is made up of, and that's 5 and 7. 55 is made up of 5 and 11. So you've got common factors here, so that's something we can work with. And then 121 is 11 squared. So we don't need to look any further than that because we've got a common factor there and common factors there. So that's really helpful to try and find the solution here. Okay, so now for Euclid's algorithm, we can either combine these two or these two. Obviously we've got common factors there, common factors there. So my preferred way is to start one from the two largest numbers first. So I'm going to write 121 equals 55 times 2, which is 110, and then add 11. So that gives me 11 left over. And that's really useful as well because I've got an 11 here and 11 here. It's kind of what I was expecting. So I'll bring the 55 across. 55 equals a multiple of 11, which is 5 times 11, and that's plus 0. And with a plus 0 at the end, I was kind of expecting that because these have got two common factors. Okay, so now the reverse algorithm, I now start from this 11, and that equals 121 minus 55 times 2, which is just simple algebra. Bring this across here, and that's how I get that part, and then the 11 stays. Okay, so that takes care of that. Now I've not done an algorithm for 35 yet, but what I want the 35 to have a number in here that's common when I did the algorithm for these two, i.e. here. So one number I can use here is 11. So if I start off as I did with the algorithm here with the 35 first, and then a multiple of 11. So that's 11 times 3. That's 33, so I need to add 2. Okay, so next line of the algorithm, start with the 11 and a multiple of 2. So that's 5 times 2, and that's plus 1. Okay, so now that was expected to have 1 because 35 and 11 are co-prime, so that was expected to get the 1. So that's kind of a little check you can do as you're going along. Okay, so now we need to do the reverse algorithm and put the 1 first. So 1 equals 11 minus 5 times 2. So basically I've just rewritten this last line. Right, so now I need to get this involved into the reverse algorithm. Well, I know what 2 is. It's 35 minus 11 times 3. So if I just plug that in there for the 2, and that will complete the reverse algorithm. So minus 5 times, and then actually instead of putting the times, I'll just put a bracket. So for 2, it's 35 minus 11 times 3. Okay. So that's still a true statement because this is 2, 11 minus 5 times 2 gives us 1. Okay, just need to just simplify this up here a little bit because I've got 11s here and 35s here. So now my 1 equals, so 11s, I've got minus 3 and minus 5 11s. So that's basically plus 15 in this bit, so minus 3 times minus 5. And then 1 here. So that's now 16 times 11. And I've got minus 5 times 35. Okay, that takes care of that. Now, what I want to do now is take parts of this algorithm and plug them in here. Now, what I want to achieve is coefficients of this algorithm to be included in this original question. Now, I can see the 35 is in there already, but there's no 55 or 121. But I do know what 11 is in this algorithm. That's this line here, and it includes the 121 and the 55. So now I'll go 1 equals 16 times. Now I'll plug in for my 11, this line here, 121 minus 55 times 2, and then continue with the minus 5 times 35. And again, this is still a true statement because this is just 11. 16 times 11 is 176. 5 times 35 is 175. Subtract the 2, you get 1. So this statement is still true. So we know we're still on the right path. So now what I need to do is just simplify it all up. So I get 121, 55 and 35 on their own. So there's my 35, there's my 55 and there's my 121. And that's going to give me my first solution. So 1 equals, which is what we want, 16 times 121. So that's great. That's going to give us our C. And now we've got 16 times minus 2 for our 55 coefficient. So 16 times minus 2, minus 32. So minus 32 times 55. So that's our 55 coefficient, so that's our B. And then minus 5 times 35. Okay, so that's the coefficients that we need. So our A, which is the one for 35, which is minus 5. So A equals minus 5. B is our minus 32. And C is the one for 121, which is 16. So now it's always a good idea to check your answer. So 16 times 121. So what's that going to give us? 121 times 16, that's 1210. And then 6 times 121, well 6 12 is 72, so that's 726, that's 1936. So here we can plug in 1936. Okay, 32 times 55. Okay, 32 times 50, well 532s are 160, so that's going to give us 1600. And then without the extra 0, 160, so that's just 1760. And then 535s we know is 175. Okay, add these two up. 760 plus 175, that's 935, plus the 1000, 1935. So 1936 minus that gives us 1. So therefore, this is a correct solution. Okay.